Consider the game described below. So in this game, you can get a big win, a small win, or you can lose. The cost to play is $25. A big win pays $120. A small win pays $70. What is the expected value of this game? The first thing I need to do is find this missing probability. And the main fact we're going to use is that all probabilities together need to add up to 1. So I'm going to add up what I have so far. So 0.29 plus 0.65. And I get 0.94. So to find the missing probability, I'm going to do 1 minus 0.94. And that gets me 0.06. So the missing probability is 0.06. And then I need to fill out the profits. So if I get a big win, I'll get paid $120, but I have to keep in mind that I already paid $25 to play the game to begin with. So we'll take the 120 and then subtract off what you paid to play. So 120 minus 25. So if you get a big win, your net profit is going to be positive 95. So I'll write that as a plus 95. If you get a small win, you win $70, but you have to keep in mind that you already paid $25 to play. So you have to do 70 minus what you paid to play. So 70 minus the 25. And we get a positive 45. So I'll write that as plus 45. Now, if you lose, you get nothing, right? But you did already pay $25 to play. So if you lose, then you just lose what you paid. So we lose the 25. So I'll write that as minus 25 or negative 25. Okay, so once we have all the probabilities and all the profits, to find the expected value, you would just do probability times profit plus probability times profit plus probability times profit. So the expected value, I'll write as EV, is 0.06 times a positive 95 plus 0.29 times a positive 45 plus 0.65 times a negative 25. Okay, enter all of this into the calculator. 0.06 times 95 plus 0.29 times 45 plus 0.65 times a negative 25. And I get 2.5. Consider the following game. You are dealt one card from a standard deck of cards. The game costs $6 to play. If you get a red face card, the game pays $20. If you get a club, the game pays $12. If you get a red 7, the game pays $32. What is the expected value of this game? First thing we need to do is find all the probabilities. So we're talking about dealing a single card from a deck of cards. So we should these should all have a single fraction. Okay, for the bottom, it's how many different cards can we get if we deal one card. So here's my deck of cards. The total number of cards is 52. So the bottom is going to be 52. Okay, up top, how many are red face cards? So red face cards would be J, Q, K, hearts, and Jack, Queen, King, diamond. So that's 6. So 6 red face cards. Right, so I'll have to enter this into a calculator to get the decimals, but let's do that after we find the other probabilities. The second thing is getting a club. The bottom's going to be how many different cards total, so that's 52. How many clubs do we have? Clubs would be this entire first row. So the entire first row, 1 through 10, and then JQ King, that's 13. And then the red 7, the bottom is going to be how many different cards, that's 52. And then how many red 7s are there? Red 7s, I see a 7 of hearts and a 7 of diamonds, 2. All right, so now let's go through and enter these into a calculator to get our probabilities. Okay, so first one, 6 over 52, 6 divided by 52, 0.115. So let's round these to 3 decimal places, 0.115. Club, 13 over 52, that's 0.25. And then red 7, 2 over 52, that is 0.038. And then we have this missing probability. So add up what you have so far, and then subtract it from 1. Okay, so we're using the fact that all the probabilities together need to add up to 1. So add up what we have so far. So 0.115 plus 0.25 plus 0.038. And so to find the missing probability, so what I get when I add these up is 0.403. To find the missing probability, I'll just do 1 minus 0.403. Okay, so 1 minus 0.403, 0.597. So we're missing probably 0.597. Now let's talk about the profits. So if you get a red face card, the game pays $20. But keep in mind that we already paid $6 to play, so we have to subtract that off. So 20 minus 6, that's a positive 14. I'll write that as plus 14. If you get a club, the game pays $12. Once again, subtract off what you paid to play. So 12 minus 6, that's a 6. If you get a red 7, the game pays $32, but subtract off what you paid to play at the beginning. So 32 minus 6, that's 22. So that's a plus 22. Actually, it's not plus 22. 32 minus 6 is a positive 26. So that should be a 26 and not a 22. And then if you lose what you paid. So that means you'll get a minus 6, negative 6. Once we have all the probabilities and all the profits, we'll just do probability times profit plus probability times profit plus probability times profit. So the expected value is going to be the probability, so 0.115 times the 14 plus 0.25 times the 6 plus 0.038 times the 22 plus 0.597 times the negative 6. Entering all this into the calculator, 0.115 times 14 plus 0.25 times 6 plus 0.038 times 22 plus 0.597 times negative 6. 0.364. Consider the following game. You are dealt 3 cards from a standard deck of cards. You win if all 3 cards are hearts. The game costs $3 to play, and a win pays $110. So first thing we need to do is fill out the probabilities. So we're talking about selecting 3 cards. Okay, so I'll need 3 fractions. And I want all of them to be hearts. Okay, so the bottom of the first fraction, how many different cards can we pick from? Here's my cards. So there's 52 cards total. So the bottom's gonna be 52. And because we're talking about picking a card and not putting it back, for the next fraction, I do have to reduce because I already picked 1 card for the first slot. So I'm down to 51 and then 50. Now we want all of them to be hearts. So I want heart, heart, heart. How many hearts are there? Hearts are the 3rd row here. So 3rd row, ace through 10, and then jack, queen, king. So that's 13 total. And then once again, once I pick that heart, I'm not putting it back. So for the next fraction, I'm down by 1 to 12 hearts now. And I'm down again to 11 hearts. Okay, so 13 over 52 times 12 over 51 times 11 over 50. So let's enter this into the calculator. So 13 over 52 times 12 over 51 times 11 over 50. And I get 0.038. 0.013. Okay, and then to find the missing probability, we use the fact that the probability need to add up to 1. So we'll just do 1 minus 0.013. Okay, so 1 minus 0.013, 0.987. Okay, so this lose is 0.987. Now let's talk about the profits. So if you actually get all 3 cards heart, you win $110, but keep in mind that you have to subtract off what you paid to play. So 110 minus the 3 is a 107, positive. And then if you lose, you just lose the $3 that you paid, so you'll be down -3. And then to find the expected value, probability times the profit, so 0.013 times 107 plus 0.987 times the -3. And then let's enter this into a calculator. 0.013 times 107 plus 0.987 times -3. I get a -1.57. Consider the following game. You roll 2 20-sided dice. You win if both numbers are multiples of 3. The game costs $7 to play, and a win pays $100. First thing we need to do is find the probabilities. So what's the probability of rolling 2 dice and getting both multiples of 3? We're talking about 2 dice, so I'll need 2 fractions. The bottom, how many different numbers can I get? So when I roll a 20-sided dice, I can get numbers from 1 through 20. So 1, 2, 3, 4. So there's 20 different numbers I can get. So the bottom is going to be 20. Now, when we talk about dice, we don't reduce. So whatever you get on the first dice, you can still get it again on the second dice. So we don't reduce. Okay, for the top, how many numbers are multiples of 3? Okay, so let me go through and circle my multiples of 3. That just means I'm going to count by 3s. So 3 plus another 3 is 6, plus another 3 is 9, plus 3 again is 12, plus 3 is 15, plus 3 is 18, and that's it. Okay, multiples of 3, that's 1, 2, 3, 4, 5, 6, so 6. And then for the second fraction, I also want to be a multiple of 3, but because we're talking about dice, we don't reduce, so we still have the full 6. And then let's calculate this. 6 over 22 times 6 over 22. Or I mean 6 over 20 times 6 over 20. 0.09. And then to find the missing probability, we'll just do 1 minus that. So 1 minus 0.09 is, I think, 0.91. Yep, 0.91. Okay, and now let's talk about the profits. So if you win, you get $100, but you have to subtract off what you paid to play. So 100 minus the 7, that's a 93, positive. And if you lose what you paid. So if you lose, you get a -7. And then to find the expected value, probability times profit plus probability times profit. So 0.09 times 93 plus 0.91 times the -7. All right, so 0.09 times 93 plus 0.91 times -7. I get a 2. Consider the following game. You are dealt 3 cards from a standard deck of cards. You win if you get at least one diamond. The game costs $3 to play, and a win pays out $12. So what's the probability of dealing 3 cards and having at least one of them diamond? Keyword here is the word at least one. So anytime we're looking for an at least one probability, it's going to be 1 minus none. So we're using a complement here. So 1 minus none diamond. So I need, how many fractions do I need? We're talking about 3 cards, so I need 3 fractions. So 3 cards, none of them diamond, means I want not diamond, not diamond, not diamond. So not diamond. All right, so bottom of the first fraction, how many different cards can I get? So here are my cards. There's 52 different cards. And then we're talking about cards here. I'm dealing a card, but I'm not putting it back into my deck. So when I go to the next fraction, the total different cards is now down by 1 to 51, and then down to 50. So 3 cards, none of them diamonds. I want to be, that means that I want them to be not diamond, not diamond, not diamond. How many not diamonds are there? So not diamonds would be the first 3 rows. Okay, so first 3 rows, each row has 13. So 13 times 3 rows, that's 39. And then second card, I want also to be not diamond. So once again, because we're picking these cards and not putting it back, for the next card, because I already picked one not diamond, I should be down to 38 not diamonds total, and then 37. Okay, so let's enter this to the calculator. 1 minus 39 over 52 times 38 over 51 times 37 over 50. And I get 0.586. So I'll write that right here. Okay, so 0.586 is the probability of getting at least one diamond. Lose, you just do 1 minus that to get the lose. So 1 minus 0.586. And that is 0.414. And now let's talk about the profits. So if you get at least one, then you win. You win $12. But keep in mind that you already paid $3 to play, so you have to subtract off the cost to play. So 12 minus the 3 is 9 positive. And then if you lose, you just lose what you paid. So you'll be down 3, so that's negative 3. And then to find the expected value, probability times the profit, plus probability times the profit. Okay, so 0.586 times 9 plus 0.414 times negative 3. 4.032. Consider the following game. You roll 2 20-sided dice. You win if you get at least one number that's bigger than 15. The game costs $7 to play, and a win pays out $10. So if I roll 2 20-sided dice, what's the probability that I get at least one that's bigger than 15? So keyword there is at least one. So anytime I'm looking for an at least one probability, I'm actually going to use the complement. And so my final answer will be 1 minus the probability that none of them are bigger than 15. So how many fractions do I need? Rolling 2 dice, so I should have 2 fractions. So 2 dice, none of them bigger than 15, means that I want both of these to be not bigger than 15. Okay, so when I roll a dice, how many different numbers can I get? We're talking about 20-sided dice, so I can get numbers from 1 through 20. Okay, how many different numbers are there? There's 20 of them. And because we're talking about dice, whatever I get on the first dice, I can still get again for a second dice. So I don't have to reduce for dice. So the second fraction will also be 20 different numbers. And then how many of them are not bigger than 15? So let me first circle the numbers that are bigger than 15, and then the not bigger than 15s will be the other numbers. Bigger than 15 means you don't include 15. So bigger than 15 would be 16, 17, 18, 19, 20. Okay? For these two fractions, I want the numbers that are not bigger than 15. So what numbers are not circled? Not circled would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 of them that are not circled. And then again, we're talking about dice, so we don't have to reduce. So second fraction will also be 15. So enter this to a calculator. So 1 minus 15 over 20 times 15 over 20. 0.438. And then to find the missing probability, we'll just do 1 minus that. So 1 minus 0.438. 0.562. And now let's talk about profits. So if you do get at least one that's bigger than 15, you'll win $10. But remember, we have to subtract off what we paid to play. So 10 minus the 7, that ends up being a positive 3. And then if you lose, you just lose what you paid. So you should be down 7. So that's a negative 7. And then to find the expected value, probability times profit, 0.438 times 3 plus probability times profit, 0.562 times the negative 7. And then into our calculator, 0.438 times 3 plus 0.562 times negative 7. Negative 2.62.